So today's lesson is about the approximation of the binomial distribution. And that actually happens because of a thing called the limiting process, i.e., if the size of our binomial distribution gets really big, it essentially becomes a normal approximation. Now, the normal approximation is always a continuous distribution, but when you're looking at real world experiments, studies, etc., these are often discrete distributions, discrete data points. Let's call it that. Which means that we have to use discrete distributions. Now, that is to be expected if you think about it, right? Now, basically, these discrete distributions are ridiculous to calculate. Often when you do these, you end up using spreadsheets. You end up using spreadsheets to do the calculations for the discrete distributions, right? Or programs that you create. Because sometimes the numbers n is too large, right? Now, basically what you need to understand under certain conditions, the binomial distribution can be approximated by the normal distribution. So, based on this revelation that I told you earlier, this is what you need to know about the conditions to use the normal distribution for the binomial distribution. Here it is. 1, each trial has to be identical. Okay, now the next thing is 2. Each trial must be independent. And 3, you either have a success which we called P, and a failure, condition we called Q. And Q was no more than 1 minus P. Think of it that way. Now, all this describes as a binomial distribution. But the binomial distribution is represented by the normal distribution. And in this case, I want you to add the fact that n must be large. Large in order to get better approximations. Now, n in this case, to get a really good approximation, n needs to be bigger than 100 trials. So now I want to give you some consequences of this. To use the normal distribution, we need we need mu and sigma. So mu and sigma. Mu was our mean, remember? And sigma was our standard deviation. Okay? So in order to calculate that using the binomial distribution, you're going to use this. Mu, I'm going to put it in black. Mu was equal to n of p from our binomial distribution, and our sigma, which is called the variance. Remember, the variance is the square root. The variance is the standard deviation squared. So you've got n times p times q. And we also have to make sure that instead of n being greater than 100, we have to actually check to see that np is greater than or equal to 5. And for this course, you're also going to say that n of q is greater than or equal to 5 as well. So all of those things, those three equations, can come out of what we've got here. So here's our problem. Suppose you have the roll of the die, and you're rolling this thing 72 times. So n is 72, right? And what you need to do is you need to have a success as having either a, what would you call it, a 2 or a 4 as our success. So for our success, that's our p-value. P is equal to just 2 over 6, which gives us p equaling 1 over 3. Similarly, for the failures of this description here, you've got q is equaling, well, 2 over 6, 4 over 6, which is just 2 over 3. So q is 2 over 3. Now, if I was looking at this problem, it says you're going to basically roll a die 72 times by either rolling a 2 or a 4. So this looks like a binomial distribution, and that's what we were using here and here. Now, find the probability of winning 30 times or less. So if we actually did that, we would start by using our binomial distribution. So p of x being less than or equal to 30. Okay, let's go through. So we go and find the probability of 0 plus the probability of 1 plus the probability of 2. Oh, it goes on forever. All right, so that's your hint that you're going to go and change this into a normalized distribution. Now, let's check. So it's a candidate. So I'd say this is a candidate for normal distribution. And this is how we check. We take a look at n times q and n times p. N times q is 72 times q, which is 2 over 3. And we're also going to go and take a look at n times p, which is 72 times 1 over 3. Now, you get the following answers for p and q. I mean for np and nq. So you got np is 24 and nq is 48. And remember, both of these had to be greater than 5. So guess what? We can change this into a normal distribution. Now, in order to find the mu of our normal distribution, we literally have to go and say mu is equal to np. So n is 72, and we're going to multiply that by 1/3, which is 24. And then we also have to calculate the standard deviation. And the standard deviation is always going to be s is equal to the square root of the following: n times p times q. So n times p times q is 17 times 1/3 times 2/3. Oh, sorry, not 17, it's 72. I apologize. So let's make sure we put 72 times 1/3 times 2/3. Punch that in your calculator. You end up with the square root of 16, which gives us 4. So we're going to assume that the normal distribution X is the normal distribution with the following. You've got a mean of 24 and a standard deviation of 4 for our normal distribution. And so now when we're calculating the probability, you're probably calculating the probability of X being less than 30. Okay? So to calculate something less than 30 for a binomial distribution, which is, or if you think about it, which is discrete points, we're going to have to actually use the value of the probability of X being less than 30.5 to calculate what we're looking for. And so now what we're going to do is we're going to calculate the Z-score quickly for this problem. Okay, so the Z-score is equal to X minus the mean divided by the standard deviation. So you're going to get 30.5 minus 24 divided by 4. And that gives us approximately 1.63. Then what we're going to do is we're actually going to calculate P of the Z being less than 1.63. And then all we have to do is refer to our Z-score table to get our probability, which gives us 0.9484. And this tells us, therefore, the probability of winning times or less is about 95%. And we're done. So now let's go and take a look at the next problem here. It's saying, what is the probability of winning exactly 30 times? So we've taken a look at that already. So in order to do that, you're going to say, okay, B is equal to the probability of X equaling 30, which is just, if you recall, based on our charts, based on our Z-score chart or our normal distribution chart, you've got something that looks like this, right? So now when we're looking for X is equal to 30, we're going to have 30.5 above and 29.5 below to get this chart. So we got the bottom half here, and then I'm going to use my highlighter and the top half here to get the green bar here, which represents a value of 30. So we're going to go and calculate the probability of X being less than or equal to, sorry, not less than or equal to, but less than the probability of X less than 30.5 minus the probability of X being less than 29.5. Do your calculations by going to your Z table. And in order to do that, we have to make sure we get our Z table for this part here. But right now, all we're going to do is calculate this. P of 30.5 we found to be about 0.9484 minus the Z score of this, P of Z being less than 1.38. Now, if you don't remember how to do it, just refer to the previous example to find the Z score for 29.5. So you've got 0.9484, and you're going to be subtracting from 0.9162, and that's going to give us the answer 0.0322. Therefore, the probability of getting 30 is 3%. So now let's go and do the last problem. So the last problem says, what is the probability of getting between 30 and 36 times? So the probability of getting between 30 and 36 times is this. So this is C, the probability of X being less than 36 but greater than 30 is going to equal the probability of, well, 29.5 less than X, which is less than 36.5. So we know we need to find the probability of the z-score for 36.5 and the probability of the z-score for 29.5. So it's X being less than 36.5 and X, probability of X being less than 29.5. We already found the z-score for 29.5, and it was the probability of Z being less than 1.38. But now we have to calculate the z-score for X equals 36.5. Doing your calculations, you find your z-score equaling less than 3.125. And then referring to your z-score table, you're going to get the following. You've got, for this first one, you've got 0.9991 minus 0.9162. And then what we're going to do is we subtract and we get our answer of is approximately 0.083. Therefore, the probability of winning between 30 and 36 times is 8.3%. So here's our last problem. Soft Company knows that it has 42% market share of one region. The marketing department conducts a blind taste test on 70 people. So in this case, here's what you need to know. N is equal to 70, right? Answer the following. Determine the probability that fewer than 25 people will choose their drink. So the fact is they say that there is a 42% market share. So for winning, we choose their stuff. So it's N. So P is equal to, so P is equal to 0.42. All right. And then for not choosing, this time for this binomial distribution, you got Q is equal to 0.58. All right. And now it says determine the probability that fewer than 25 people try to do this. So if I try to use binomial distribution on this, it's just too cumbersome. So let's check. So our check is NP. NP is equal to 70 times 0.42. And our second check is NQ, which is equal to 70 times 0.58. For each of these, you get these. So in checking NP and NQ, they are both greater than 5, so we can use the binomial distribution as a standard, as a normal distribution. So we're going to go and do the normal distribution for this thing. So we do the normal distribution. So remember, we already calculated our mean. Let's call it mu. Our mu value was 29.4. We calculated it before, but now we have to calculate our standard deviation, which is equal to the square root of n times p times q. So S is equal to the square root of 70 times 0.42 times 0.58. And taking the square root, you're going to get approximately 4.1 for your standard deviation. So we're going to determine the probability using the normal distribution for x, where our mu is 29.4 and our standard deviation is 4.1. Well, 4.1 squared. All right, so now let's figure out the probability of x being less than 25 people, which really means we want the probability of x being less than 25.5 people. So now we're going to calculate the z-score. And when you calculate the z-score for 25.5, you get negative 0.95. And then when we refer to our z-score table, we have this probability, which equals 0.1736. So therefore, the probability of fewer than 25 people choosing our stuff is, let's say, about 17%. So now let's go and calculate the probability that exactly 40 people will choose our drink. So for this one, for part B, again, we're going to go P of x equals 40, which is equal to P of x being between 40.5 and 39.5. So then what you're going to do is you're going to take the probability of x being less than 40.5 and then you're subtracting the probability of x being less than 39.5, which gives us these probabilities with our z-scores of z being less than 2.71 and z being less than 2.46. So for z of 2.71, you've got 0.9961 minus 0.9331, which gives us an answer of 0.0035. So here's what you would say for your answer. For your final answer, you're going to say this. You're going to say that to get 40 people, 70 to like your product, exactly 40, then you're going to have a probability of 0.35% probability. Now, what I'd like you to do is do the work that I've posted online for you.